Okay, so you interact with these recommender systems,
Hmm.
like constantly, right? Maybe dozens, even hundreds of times a day without really thinking about it. They're behind what you watch, what you buy online, the news you see. But how do they actually work? How do they figure out what you want?
Yeah.
Sometimes it feels like they know better than you do. You sent over a really interesting set of sources that go deep into this. They cover the core concepts of the different kinds of systems, the challenges, and even how we judge if they're any good.
Exactly. It's a fascinating area. And yeah, the material you shared is a great guide through it all. Our plan for this deep dive, really focusing on your sources, is to unpack those key ideas, maybe find some surprising details, and get those aha moments about what's really going on when you get a recommendation.
Perfect. Let's jump in. We probably all get the basic idea of recommendations, but your sources dig into how the predictions are made. They start with this idea of filling in a huge grid.
That's the classic way to think about it, yeah. Predicting a user's preference or utility for something. Imagine this giant table, users down one side, items across the top. Most of it's empty because you haven't rated everything. The system's job is basically to guess what ratings would go in those empty spots, then recommend the items with the highest predicted scores for you.
So fundamentally, it's about helping you cut through the noise, right? When there's just too much stuff out there and you don't know where to start.
Precisely. Movies, products, news articles. You can't possibly check everything, so the system tries to narrow it down for you.
And it's not just about the prediction anymore, is it? The sources mention things like trust and explainability becoming more important.
Definitely. It's moving beyond just what to recommend. Then it's also about why you should trust it, and understanding the logic behind the suggestion adds a whole new layer.
Okay, so how do they actually make these predictions? The material highlights two big foundational approaches. Seems like everything builds on these. Content-based and collaborative filtering. Let's tackle content-based first. What's the main idea there?
Right. Content-based is all about you and the items themselves. It builds a profile of what you like based on the features, the content of things you've liked before. Then it hunts for new items that have similar features matching your profile.
Ah, okay. So if I'm really into, say, sci-fi books with complex world building and maybe a bit of political intrigue, the system looks at the content of books I've rated highly, keywords, genre tags, maybe even writing style analysis, builds my specific taste profile, and then it scans new books, analyzes their content, and finds ones that look like a good fit for my profile.
Exactly that. They pull out those features, often from text descriptions or metadata. The sources mention using things like machine learning classifiers like naive Bayes, or sometimes simpler stuff like weighted averages of the features from items you liked. It's all about that profile-to-item feature matching.
And what are the upsides to doing it that way?
Well, a big advantage is recommending new items. The item cold start problem. If a brand new book comes out that fits your profile, it can recommend it right away, even if nobody else has rated it. They're also good if you have very specific needs you can state.
But I feel like I've seen this happen. You just get shown more and more of the same kind of thing. It gets a bit boring.
That's the main drawback the sources point out, over-specialization. It sticks so close to what you've already liked that it doesn't often branch out, so you get less diversity, and it's harder to stumble upon something surprisingly different but still great. That's low serendipity, low novelty.
And they struggle with new users too, right?
Yeah.
If you haven't rated much yet.
Absolutely. That's the user cold start problem. It needs a decent amount of your reading history to build that personal profile. Without it, it doesn't know what makes you tick.
The material also connects content-based to a couple of other ideas. Knowledge-based systems, which sound similar but add more explicit requirements and interaction, and hybrid systems. We can maybe circle back to hybrids. Let's switch gears to the other big one, collaborative filtering. How's that different?
Collaborative filtering looks outwards, not inwards. Instead of just your profile and item content, it taps into the wisdom of the crowd, the collaboration of other users. It finds patterns based on how the whole community interacts with items.
Okay, so this is more like the people who bought this also bought, or are finding your taste buddies online.
Pretty much. And historically, a big challenge here was dealing with those mostly empty rating matrices we talked about, trying to fill in the gaps. That's the matrix completion problem.
And your sources break collaborative filtering down further, right?
Yeah.
Into a couple of main types.
Yes. Broadly into neighborhood methods, which use the raw rating data directly, and model-based methods, which learn an underlying model. Within neighborhood methods, you've got user-based.
Right, where it finds users who are similar to you, maybe using math like Pearson correlation or cosine similarity to see who rates things similarly. And then it predicts what you'll like based on what they liked.
Exactly. Pearson looks at how similarly users rate things compared to their own average, while cosine looks more at the overall pattern or direction of preferences. But the sources do note that user base can struggle with scaling up to huge numbers of users, and sometimes the accuracy isn't perfect.
And the alternative neighborhood approach is item-based.
Yep. Item-based finds items that are similar to each other based on how all users have rated them. Then, to predict your rating for item X, it looks at your ratings for items similar to item X. The material suggests item-based often gives more relevant recommendations, but maybe less diverse ones than user-based.
Interesting. And the sources mentioned clustering users or items can help speed these up and make them tougher against fake profiles.
That's right. Grouping similar users or items can definitely help with efficiency and make the system more robust.
Okay, so that's neighborhood methods. Then there are model-based methods. They learn a model first. Could be standard stuff like naive Bayes, but you lose some interpretability.
Yeah, it can become a bit of a black box, but this is where things got really powerful with techniques like latent factor models, especially matrix factorization. Your material highlights this quite a bit.
Okay, this feels important. Not just looking at who rated what, but digging deeper for hidden connections.
Exactly. It's a really clever idea. Instead of dealing with that massive sparse rating matrix directly, you try to approximate it by multiplying two smaller, denser matrices together. One matrix represents users, the other represents items, but they don't represent them directly. They represent latent factors, hidden features. Let's say matrix R is ratings, U is user factors, V is item factors. Then R is approximately U times V transposed.
And these latent factors aren't obvious things like genre, but sort of hidden concepts. Like a user factor might capture an affinity for dark humor, and an item factor might capture how much a movie has dark humor, even if it's not explicitly tagged.
Precisely. It's like discovering the underlying dimensions of taste that explain why certain users connect with certain items, and how do they find these factors. The sources mention methods like stochastic gradient descent, SGD, which basically means you start with a guess for the factors, look at one rating, see how wrong your prediction is, and nudge the factors a tiny bit to make it better, repeat millions of times, or alternating least squares, ALS. That's where you kind of hold the item factor still and solve for the best user factors, then hold the user factor still and solve for the best item factors, and go back and forth. They also mention common challenges like overfitting, making the model too perfect for the training data so it doesn't work on new stuff, and using regularization to keep the model simpler and more general.
The sources also bring up graph-based methods here, thinking of users and items as points on a network.
Yeah, you can represent the user-item interactions as a graph. Then you can use techniques like random walks or algorithms similar to Google's PageRank, but personalized, to find related items or users. They even mention something called FolkRank, which tries to specifically filter out recommendations that are just based on pure popularity.
And quickly, association rules were also mentioned, finding items often rated together.
Right. Looking for rules like, if a user interacts with item A, they are likely to interact with item B. Defined by metrics like support, how often A and B appear together, and confidence, how often B appears when A does. It's another way to mine those interaction patterns.
Okay, wow. So those are the foundational pillars: content-based, looking at item features; collaborative, looking at user behavior, with different spins like neighborhood versus model-based. But recommendations aren't always just for one person in a vacuum. Your sources get into more complex situations, like what about recommending something for a group?
Ah, yes. Group recommender systems. Exactly what it sounds like, trying to find something that works for a group of people. Think about picking a movie for movie night with friends, or music for a gym, or a holiday destination for a family.
Yeah, I can see how that gets tricky fast,
Yeah,
especially if the group has really different tastes.
totally. Just averaging preferences often leads to something nobody loves. The sources say the field is moving beyond simple averaging to consider group dynamics, things like how people influence each other, maybe conformity, or even emotional contagion within the group.
Another really relevant area is context-aware recommendations. Makes total sense with mobile devices and everything.
Absolutely. The core idea is simple. The best recommendation might depend on more than just who you are and what the item is. Context matters, like when is it, time of day, season, where are you, location, who are you with, social context. The sources nicely describe this as moving from that flat 2D user item matrix to a multi-dimensional cube where context adds extra dimensions.
And they talked about three main ways to handle context.
Right. One is pre-filtering. You filter the data based on context first, then run a standard recommender on that subset. Another is post-filtering. Run the standard recommender, then adjust or re-rank the results based on the current context.
And the third way is to build the context right into the model itself.
Exactly. Things like tensor factorization or other generalized models that treat context as just another dimension in the prediction problem. It's more complex, computationally heavier, potentially more powerful if you have enough data. They give examples like time considering recency, but also contextual time, like time of day or day of week effects. Maybe you like different music during your morning commute versus Friday night. They even mention modeling how preferences might drift over time. And location is a big one, obviously. Location-aware systems are kind of a special case of context-aware ones, looking at how geography affects taste preference locality.
Then there are social and trust-centric systems, using our connections.
Yep. Leveraging things like your friends list, follower networks, or even explicit trust statements between users. The system might trust recommendations from people you trust, or people trusted by people you trust propagation.
Social tagging systems also fit here, right, where users add tags to items.
Right. You can then recommend items based on tags, or recommend tags themselves, or even recommend users based on shared tagging behavior. Though the sources do flag challenges like tags being sparse, ambiguous, polysemy, or overly personal idiosyncrasy.
And one more advanced type mentioned was multi-criteria recommender systems. This sounds useful for things like restaurant or hotel reviews.
Definitely. It's when users rate things on several different aspects, not just an overall score. Like for a hotel, rating the location, the service, the cleanliness, and giving an overall rating.
Because just looking at the overall score can be misleading. The sources had that example. Alice and Bob both give an 8/10, but for opposite reasons.
Exactly. Alice might love the plot, but find the acting, meh, 6/10, while Bob finds the plot weak, 6/10, but loves the acting, 10/10. Overall, both 8/10. If you only see the 8, they look similar. But if you look at the criteria, Alice might actually be much more similar to Sayani, who also rated plot high and acting lower. Ignoring the criteria misses the real preference nuances.
Okay, that covers a huge range of approaches from the basics to these more sophisticated contextual and multifaceted systems. But it's not all smooth sailing. Building and running these things involves some major headaches, which your sources definitely cover.
Oh, absolutely. We've touched on some already, but yeah, sparsity and cold start are perennial problems. Most users rate few items, making predictions tough, especially for new users or items.
And privacy. That looms large, doesn't it, given how personal some of this preference data can be?
Hugely important. Political leanings, health interests. This data can be very sensitive. The sources mention how privacy concerns actually hindered progress after things like the Netflix Prize dataset release, because researchers became warier about sharing potentially re-identifiable user data.
Then there's the issue of attacks. People trying to game the system.
Yes, making the systems robust is critical. Malicious users, maybe competitors, or even manufacturers can inject fake profiles or ratings to push their own items up or push rivals down. The sources describe specific attack types, like a love-hate attack, rating the target item badly, lots of others highly, or a reverse bandwagon, rating the target badly, along with other genuinely unpopular items to make the profile look more normal. Attackers have different strategies, balancing how effective the attack is versus how much they need to know about the system.
And some algorithms are easier targets than others.
Seems so. The sources suggest user-based neighborhood methods might be more vulnerable than item-based ones, for instance, so building in robustness is key. Things like the clustering we mentioned earlier can help dilute the impact of a few fake profiles. They even talk about metrics to measure attack impact, like average prediction shift. Interestingly, trust-based systems might inherently be more robust because it's harder for fake profiles to build up genuine trust links.
And to help with sparsity and cold start, the sources talk about active learning.
Right. This is a proactive approach. Instead of just waiting for ratings, the system strategically asks for specific ones it thinks will be most informative.
Like, we see you like sci-fi, but you haven't rated any fantasy novels. Could you rate these 3? To fill in gaps in its knowledge about your taste.
Exactly like that. It's about optimizing the data gathering, acknowledging that getting user feedback isn't free, it takes user effort.
So given all these different methods and all these challenges, how do we actually know if a recommender is good? It's clearly not just about predicting the exact star rating.
No, definitely not. Prediction accuracy is one piece, but the sources really emphasize evaluating other qualities. Things like diversity, does it show you a range of things? Novelty, does it suggest items you didn't already know about? And serendipity, the really valuable one, does it suggest things that are surprisingly relevant?
How do you measure surprisingly relevant? That sounds tricky.
It is. The sources mention a couple of ways. Online, you could directly ask users, was this useful? And was this obvious to you beforehand? Serendipity is finding things that are useful and not obvious. Offline, you could compare your fancy system's recommendations against a very basic, content-based system, which tends to recommend obvious stuff. The serendipitous items are the useful ones your system found that the basic one missed.
And because we usually get lists, not single items, metrics that evaluate the ranking are important too.
Crucial. You don't just care if the right item is recommended, but how high up the list it appears. The sources mention things like average reciprocal hit rate, ARHR, which gets more credit for getting the right answer near the top.
And while offline tests are useful for developers, the sources stress that you really need real users to test things like usability and, importantly, trust.
Absolutely. Perceived trust is huge, and that ties directly into explanations. Why is it so important for systems to explain why they recommended something?
Well, the sources list several good reasons. It builds user trust, obviously, makes the system less of a black box transparency. It helps you judge the recommendation better yourself. It can help you discover why you might like something new. And it can even explain why something wasn't recommended.
And the kinds of explanations you can give often depend heavily on the underlying algorithm and how you actually present the recommendations.
Which brings us to user interaction design, how the recommendations look and feel.
Right. The interface matters. A simple list is common, but the sources mention alternatives like visualizing recommendations on a map or more graphical interfaces for shopping. How you interact, can you tweak the recommendation? Give feedback easily. It all affects the user experience. Good systems need to balance that prediction quality with making it easy and low effort for the user.
Okay, so if we step back and look at everything covered in the material you shared, what's the big takeaway?
I think it's the sheer breadth and depth of the field. You've got these foundational approaches, content-based and collaborative, each with their strengths, one using item DNA, the other using the crowd. Then you layer on more sophisticated techniques like finding latent factors, incorporating real-world context like time and location, handling groups, leveraging social trust.
And each one is trying to solve slightly different parts of the puzzle, dealing with those persistent challenges like having too little data, or needing to start fresh with new users and items, or fighting off manipulation.
Exactly. It shows a field that's constantly innovating, moving beyond just pure accuracy to think about the whole user experience, diversity, novelty, trust, transparency, ease of use. It's complex.
This has been incredibly insightful, really unpacking the layers from the sources you provided. It gives a much clearer sense of the cleverness, but also the real difficulties behind these systems we use every single day.
Glad it was helpful. Yeah, the sources gave us a lot to work with. It's a really critical piece of modern technology.
So as we wrap up this deep dive, maybe a final thought for you, the listener, to chew on. We're seeing these systems get smarter, more personalized. How do you think future recommenders will or should strike that balance? The balance between giving you those amazing serendipitous discoveries versus ensuring you still feel in control, that the system is transparent, and that it's robust against being manipulated. Where's that sweet spot?
That's definitely the million-dollar question going forward, a fascinating challenge.
We hope this exploration, based on your materials, shed some light and maybe spark some new questions for you to explore further.